Alright, this lesson is going to be all about series circuits. Just going to be conceptual right now. I'll teach you about the math later. But back in PhET, we're going to go to the circuit construction kit right here. You don't have to use this for this lesson, but I will have you guys actually open these up in the next couple days to create circuits, and then you can take screenshots using this simulation. So getting to it real quick, try not to waste a bunch of time. I'm going to make our simple circuit that we've already built. Try to space it out pretty nice for us. And I'm just going to put in one light bulb to start with. And I'll actually add a switch just to kind of space things out. One more wire. Alright, I'm kind of going overboard with the wires, but you'll see why in a second. So anyway, the one thing is the switch won't let the current flow, and we've already known that electrons are the charges that move. But just for the sake of the concept builder that you're going to get for your homework today, you need to be mindful that this shows what actually happens, but what the concept builder and what I've already talked about Tuesday and Wednesday before I last saw all of you is that we actually call it conventional current, which is the protons moving. So the conventional current is actually always going to go positive to negative. So in this circuit that I set up, conventional current would be clockwise, which I know the simulation shows the opposite. Just don't let that confuse you. But anyway, it shows the current flowing, which in the concept builder, you'll use what they call arrow tails. You'll kind of see these arrows with a certain amount of lines indicating how much the current is. And then you'll also see these brightness lines on the bulbs to just see, well, how bright are they based on the current that's going to. Anyway, though, this is not a series circuit. All right, there is one path, but a series circuit means that you would have multiple light bulbs or resistors in series, which means one after another on this path. So what I'm going to do is actually I'm going to delete the switch. And I guess before we do it, we can notice the brightness of the bulb and how quickly the charges are flowing. Because remember, current is how much charge is flowing by a certain point in a certain amount of time. So that could be something you need to know for the concept builder. But anyway, the brightness of the bulb is dependent upon that. So if I delete this switch, notice how big the arrow tails are. All right, if I put in another light bulb, if you think about it, this one's actually going to be the easiest, a series circuit. I've now added another identical light bulb, which is a big deal, that has the same resistance. So you guessed it, if they're in series one after another, kind of like our potentiometer, the charges have to fight through even more resisting material. So if you add another resistor in series, which a light bulb is a series, the total resistance is going to go up, which then the total current should go down. You can see the charges don't flow as much in a certain amount of time, and the light bulb brightness is the same. There is one major thing, though, that is a big time rule that we're going to want to know in the future. The big rule is that in a series circuit, the current is the same throughout. So if you notice all these charges, no matter where I'm at, they're all moving the same speed, technically, if you want to say that. So you have the same amount of charge passing some place in the same amount of time. It's also showing that it's the same current because this bulb brightness is the exact same bulb brightness as this. I'm going to start an analogy with you guys, talking about water flowing in a river, which we talked about before. And basically, if you have one path and it never separates into multiple paths, like a split or what we call a junction, that means that your amount of charge, or with a river water flowing, is the same at all times. So in a series circuit, once you have it set up, the current flowing will be the same everywhere else. All right, now, some general rules just to go off of my previous video. What happens, though, if we do kind of change the circuit and increase the voltage? Well, we already learned from Ohm's law that it's a direct relationship. So if the voltage goes up, so does the current. What about resistance, though? Well, it's kind of cool with this simulation is I can click on the bulb. If I actually increase the resistance of one of these bulbs, then it will actually get a little bit less in terms of the current. All right. Don't worry so much about what the other bulb was doing in terms of the brightness. What they're going to ask you more about is, well, what if you take another light bulb and you add another light bulb to this? So if I put this one here, we should see, because they're in series, an even higher resistance because it's, again, more material, and the total current should go all the way down. All right, in the concept builder, they're all going to be identical bulbs, so I probably shouldn't have done the last one where I changed its individual resistance. Instead, let's just add more in series to then show that, well, total resistance went up now, so the total current should go down. Big idea, though, is the total current actually stays the same. All right. I think I covered most of what you need for the concept builder, guys. That's going to be your homework for today. Submit it in Canvas like we always do. Definitely get that done before 3 o'clock. I'll send you guys the reminder and everything. If you do have questions, though, post them to the discussion thread that I started, and I'll reply to you guys. I'll check it periodically throughout the day, and then everybody can refer to that, okay? All right, good luck, guys.